Hello everyone. In this video, we will see how we can use Atom to create point-to-multipoint Ethernet services that transport all traffic on an endpoint across a BGP network core using QinQ endpoint interface types and flexible Ethernet services as a physical encapsulation type. We'll look at a scenario where normalization is set to not required. Atom offers predefined service definitions in the form of a profile that one can choose from to create a particular service. A profile captures the commonly used parameters in a service. You can either edit them or you can create your own variation. Let us take a look at a service definition for ELAN hub and spoke with QinQ encapsulation. Here we can see that the service type is set to ELAN point-to-multipoint. The instance type is set to VPLS and the signaling protocol is BGP. The route distinguisher is set to autopick and is pointed to a profile on Atom's resource manager under the IPAM. Since this is hub and spoke scenario, the route target is automatically assigned as a hub route target through autopick from resource manager under IPAM. The MAC learning is set to true. The PEC interconnect has the following settings. The VLAN tagging is set to QinQ and the physical interface encapsulation is set to flexible Ethernet services. The logical interface encapsulation is set to VLAN VPLS. The traffic type is set to transport all traffic as per the service requirements. The VLAN normalization is set to normalization not required, but Atom supports other normalization scenarios as well. The rate limiting is enabled and can be changed during service creation. The QoS is enabled as well. Let us now try to create a service. The template is already imported. The initial set of parameters include the service name and the customer. The service definition is set to ELAN hub spoke QinQ All-VLAN, which is the profile we just reviewed. Rest of the parameters will be taken from the profile itself. Since we have chosen normalization not required, no VLAN tags need to be entered. The CFM template is selected from the CFM profile. The site settings capture the PE details. In this service, we'll have two or more site settings. One will be for the hub site and other for the spoke site. We can add additional hubs and spokes as well. We can see the device IP and the interface details. The unit and the VLAN allocation is automated from the resource manager profile under Atom IPAM. The rate limit can be modified if necessary, and the class of service template is chosen from the cost profiles. The node settings is where we set the role of the device, and we have set it as hub for this particular device. On the site settings for the spoke, we have similar configuration. And in the node settings, we have defined the role as ELAN spoke. Let's try to create the service now. As you can see, a new service has been created. Let's take a look at the tasks to see the provision commands. The initial set of configuration includes a class of service configurations. We can see the forwarding class is set to best effort and the code point associated is shown as well. The forwarding class is mapped to Q0 to forward the traffic. This is based on the class of service profile. We can also see the scheduler configuration linked to the queue to regulate the priority, buffer size, transmit and shaping rate. The configuration related to interface linking to class of service is seen as well. Rest of the configuration includes firewall and policy configuration, encapsulation configuration, and CFM configurations. We can also see the outer VLAN tag that has been allocated. Since it's for all VLANs, we don't have a specific range mentioned. We can also see the policy option configurations that governs the route characteristics and the actions to be taken on the matching routes. We can see a couple of policies created to handle the scenarios. We can also see the routing instance configurations where these policies have been applied. We can also see the site configurations where we can see the name hub and its corresponding configurations. The spoke has similar configurations as well. On the hub device, we can see the policy options which have the actions to be taken on the routes. We can also see the community names that are associated with these policy statements. We can also see the routing instance configurations where the site is identified by the name hub and its corresponding interface. We can also see the CFM configurations as well. On the interface, we can see the encapsulation information, the outer VLAN tag, and the class of service is attached to that interface. The firewall and policy configuration can also be seen. The interface is also attached to the routing instance. We can also see the class of service configuration that includes DSIP configurations, forwarding class configurations, and scheduler map configurations. On the spoke device, we have similar configurations, and the site is identified as spoke 1 as per our inputs. The interface and the class of service configurations can be seen as well. Thanks for watching.